Welcome back, matriculants, and on this video or lesson we'll be looking at limits. This is a small section of differential calculus, and like I said when I was talking about functional notation in the first video and average gradient in the second video, that these subtopics are building block to the real core of calculus, which is differentiation and application of calculus when we're looking at your graphs, your optimization, and so on and so on. So this may look or sound like it's not that important, but trust me, you have to make sure that you understand these concepts before we get to the real stuff. Now, what are limits? Now, when you think of limits, you think of the maximum. If you think of limits, as commonly used, you'll find that on the roads you'll come across speed limits, which says in this zone you can only travel at 120 kilometers per hour. That is a limit. It means you can approach the 120 kilometers per hour, but you cannot go beyond the 120 kilometers per hour. As I may explain what our limits are. Now, in definition, limits is a value that a function approaches as the input approaches the very same value. Okay, now you hear me talking about approaches and approaches. Let's look at an example, because maths, it's easy when you explain through examples and you get to see the actual writing of all these definitions. So an annotation that is being used in calculus when talking about limits is written as follows. For example, let's look at this problem. It says, what is the limit of an equation x plus 2 when x approaches 4? Okay, now you may ask yourself, what on earth is this? So let me draw a visual representation of this, a graph, so that you can see what is happening. It's going to be a bit messy, but that's the best I can explain this. For now, we'll look at a visual representation, and later we'll be directly substituting into a formula and getting an answer. Okay, now this is a straight line. So this is a function y is equals to, in a form y is equals to mx plus c, which is the same as x plus 2, and it's a function f of x. Okay, so this graph I already drawn it, so it will go like this, and it will cut. Remember, this is 0, this is your y values, and this is your x values. It will cut at point 2 and minus 2 there. Now suppose we have this here, these points. If I may, I don't know if it's possible, but I want to extend this. Yes, if I may just extend this. Yes. Okay, so what does this mean? Okay, we've got 1, 2, 3, 4, 5, and 6. This x approaches 4. If I were to find the corresponding y value here, it will give me a certain y value there. Okay, this would be a point at x is equals to 4. Now, what happens when we are approaching 4? So let's say I start from 0 and I go 1, 2, 3, and 4. Let's see what happens here. Like I said, it's going to be a bit messy, but I hope you'll get the picture. Now let's look at the point at 3. If I go up there and then get the corresponding, if I go 3.1, I will get the corresponding y value. So all the values, if I go, I get corresponding y values. But look at these y values. They become concentrated there. Okay. Now I will look at the other direction. If I approaches 4, remember this is what I want to look at. If I approaches 4 from the right hand side, so let's say I start from 5, I go up 4.9 and so on and so on, I get corresponding y value. Again here I get corresponding y value. You can see these values are also becoming concentrated here. So this equation, this graph, as I approach it of 4, I get to a value that is being concentrated from either side. So the value that I'm going to get here is going to be 6. Now you may ask yourself, how did I know? How did I come to that conclusion that the value is 6? If I drew this scale and all my lines here were accurate, you will see that the value there that x approaches, it's actually 6. Okay, that's a bit difficult to explain. Let me show you why, or how I can explain this using an equation. Basically what this means is that here where we have limit as x approaches for an equation of x plus 2, I can just substitute in the value of 4 there, and 4 plus 2 is equals to 6. So this means that the limit of x plus 2 as x approaches 4, the answer that I'm going to get is 6. Okay, that's why the value that we'll get is 6. Let's look at another example. Example number 2. This one I will not explain using a graph. I will just mathematically. So we have a limit of x squared minus 25 divided by x minus 5, and this approaches 5. You will agree, grade 12s, that okay, from this equation you saw that from this moment I can substitute the value of 4 there and get an answer of 6. Now here I have a problem. If I substitute this as 5, I will get 5 minus 5, which is 0, and this whole thing will be undefined. So I must find a way of simplifying this before I can start substituting my x value. So if I look at the top part, I can see that okay, this is a difference of 2 squares. So this will give me x minus 5 and x plus 5, difference of 2 squares. And then at the bottom I got x minus 5. So this will that, and I'm left with x plus 5. Okay, so now this is the same as limit as x approaches 5, which is the same as, I don't have to write this what do you call equal sign. So we saw that this is the same as x plus 5, so it will be the same as x plus 5. Now I can substitute my y value, my x value, and say this will be 5 plus 5, which is equals to 10. So if I were to draw this graph, which is a straight line, bearing in mind that x may not be equals to 5. Okay, so if I were to draw this graph, which is a straight line, that as x approaches 5, the y value will tend to a value of 10. Let's look at the next concept, next question. Number 3. The limit of 8 as x approaches 1. Now, if you look at this problem, you will see that there's no x value here. There's no way you can substitute the value of 1. Now, let me draw a graph of this so that you can see what's happening. I have a straight line there. I have a Cartesian plane. And I have a line passing there at 8. You will see here, grade 12, that the gradient here, okay, so the value there is 8. You will see that there's no value to substitute at x. So substitute x is equals to 1. Now let's look at x at 1 here. Let's say this is 1. You will see there that as I approaches 1, the value that I get is 8. So the corresponding y value will be 8. Also here from this side, the corresponding y value that I will get is 8. So the answer that I will get here is 8 because I have no way to substitute x. So which means the limit of 8 as x approaches 1 is the same as 8. Okay. Now looking at the third example, or the fourth example, which says the limit of x minus 4 as x approaches 4. What I will do here, since I don't have a division, I can directly substitute the value of 4 here, and I will get 4 minus 4, which is equals to 8. Okay. Let's look at number 5. Number 5, which will be the last example that I'll be doing. Number 5, the limit here, I've got the limit of x squared minus 5x minus 14 divided by x plus 2 as x approaches minus 2. Again, grade 12s, you can see that if I were to substitute directly from this moment, x is equals to minus 2, I will get negative 2 plus 2, which is 0, and the whole equation, the whole expression will be undefined. So I must find a way to simplify the top part. So I will have, this will be the same as x 7 2 minus and plus. Yes. You can check that. Then this will be x plus 2. Remember, I have limit as h approaches minus 2. And then this will cancel that. I'll be left with x minus 7 limit as h approaches minus 2. And I can substitute this as minus 7 minus 9. So grade 12s, that's complete. That completes the lesson for this concept called limits. Yes, it may look like it's not that important, but you will see on the next topic, which is going to be very, very important. You will see why it was very important for me to do this subtopic, and it will be matched with average gradient until we get to a point where we do your differentiation using these principles. So from the next video, you will see that all the concepts that I've been doing, starting from your functional notation, average gradient, limits, and what else? Yes, the three that I've already covered. You will see that in the next video, they will all be merged into one topic, and we'll be looking at the core of this calculus, which is differentiation. So I hope you learned from this video. Until we meet again, have yourself a wonderful time. Bye.